Hello. Yes, we welcome you back to PSSP, Physical Sciences Silver Bullet with me, Richard here. Yeah, today we're looking at this question. It's a grade 10 question. It says that state the variation of each of the following as you move across the period from left to right. Okay, the first one is atomic radius. What happens to atomic radius as you move across the period from left to right? Okay, the answer is decrease. The atomic radius decrease. What happens is that as you move across the period, you are not adding more energy levels. It's the same energy levels, but the positive charge, which is brought about by the number of protons, increase. So that positive charge pulls the electrons closer, making the atom smaller. Yeah, then comes ionization energy. We have to recall that ionization energy is the energy required to remove an electron from the atom. And we have to take note that this electron is being pulled against the attractive force of the protons in the nucleus. So when the atom is smaller, what happens? The attractive force is stronger because the distance between the electron and the protons is shorter. So that means that you require a lot of energy to pull electrons out of the atom, making the energy required to do so to be higher. So as you move across the period, what happens to the ionization energy? It increases. Yeah, next is electron affinity. What happens to electron affinity as you move across the period? Okay, you have to know that as you move across the period, the atomic radius decreases. So decreasing of atomic radius brings the electrons closer to the nucleus. And when electrons are closer to the nucleus, it means that addition of electron will yield more energy. It's easier to pull electrons when the size decreases. So, which means that as you move across the period, the electron affinity will increase. Yeah, then we come to this one, electronegativity. Like we said, this is close relationship between these two. Both are uh, both are simply meaning love for electrons. So only that this one occurs inside the bond. So as the atom becomes smaller, its pulling power for electrons increase because the positive charge of the nucleus is closer. Whatever is pulling this electron is the positive charge in the nucleus. So if it's closer, it means that the pulling power becomes stronger. So what are you going to conclude here? It will increase. Yeah, then we come to this question. It says that consider the period 2 elements below. These are the elements we have. Okay. And they say identify the atom with the smallest atomic radius. Yeah, now we come to this question. It says that consider the period 2 elements below. These are the elements we have. and they say identify the element with 1, the smallest atomic radius. Okay. Yeah, which one is having the smallest atomic radius? Okay, this is what you have to know, that as you move across the period from left to right, the atomic size decreases. That implies that elements to the right are the smallest. So the atom is going to be fluorine. Okay. So fluorine element has the smallest atomic radius. Let us come here. The biggest atomic radius. So if atomic radius decreases as you move across the period from left to right, then it means that lithium is going to have the biggest. So the answer here is lithium. Okay, then we come to this one. The highest value of ionization energy. Which atom has the highest value of ionization energy? Okay, you have to know that ionization energy is the energy required to remove electrons from the atom. And we said that the smaller the atom, the higher is that value required. Reason being that when the atom is smaller, electrons are tightly glued to the atom, so they are not easily removed, implying that it will require a lot of energy. So in this case, the one with highest ionization energy must be the one which is the smallest, and that comes to fluorine. Yeah, then we come here, lowest electron affinity. You have to know electron affinity as the love for electrons. And we said that the smaller the atom, the more that atom will love electrons, because the attractive force, which is the positive charge, is closer. So, which means that for the lowest, the bigger the atom, the lower is the electron affinity. So the answer here is that which atom is the biggest? The answer is going to be lithium. Lithium will have the lowest electron affinity because it's big. So the pulling power for electron is small. So let us come here, highest electronegativity. So electronegativity is the ability of an atom to attract bonded electrons to itself. And here we realize that the smaller the atom, the bigger is the pulling power. So the smallest atom here must have the highest electronegativity. And the answer is going to be fluorine. Then lastly, we'll come here, highest electron affinity. Yes, the love for electron. Which of these atoms here will attract electrons strongly? The answer is the smallest. Because you have to know that smaller atoms means that the influence of the positive charge in the nucleus is stronger. So the answer here is going to be fluorine. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Servability, with me, Richard, here. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are very helpful to you. Don't hesitate to contact us in case of anything, any request. See you next time. Bye-bye.